Hi, I'm Katie Coleman, NASA astronaut Expedition 27. This is my crewmate.
Paolo Nespoli.
And we're here to do some science experiments today for the kids in Micro-G and specifically for some really interesting sixth graders at Potlatch Elementary School in Potlatch, Idaho. And today's experiment is called Pepper Oil Surprise. And I think it will surprise you. So our job is to look at what happens to things that don't mix on the ground and see whether they mix up in space or how they behave in space. And so the students at Potlatch took oil and water and put them each in a bag, and they've given me a procedure and we'll follow their procedure. They put each one in a bag, water in a bag and then added oil. We used pepper oil because that's what we have here on board. And what they found was that the oil and the water separated after just a small amount of time. And what we're going to do is see what happens up here in space. So the first challenge is to get liquids to behave up here, because up here without the force of gravity, well, other forces that are kind of small on Earth compared to gravity, like surface tension, become really dominant. So the first thing is to be able to collect our 15 mils of water that we need in our bag. Okay, so Paolo is going to help me here because what we want is 10 mils of water in this, or 15 mils of water in this bag. And I could just squirt water in there, but it's actually pretty hard to judge volume by doing that. And so one way to do it is to go ahead and take it from our bag. You can see what shape water wants to be here. And I've got a syringe. So I'm slurping up water with my syringe. The other thing you might be able to see is that now that ball of water, she wants to be on the outside of my syringe. But meanwhile, I'm collecting my water here. Okay. So that's not an exact 10, but we'll call that 8. Ah, and now we have this too. Well, there's a couple things we could do with it. Since I know that this is clean, I could eat it, but it's kind of fun just to watch it. Make sure I close our straw here. And since I know this is my drink bag, we'll go ahead and take care of this ball of water here. Okay, so we've got our first thing of water here. It's going to go in the bag, and our drink bag will just kind of sit there and hang out. It's about half of the water that we need, so we're going to do that one more time. Okay, and I should tell you that the experiment as designed asked for a bag that was pretty small, 2 by 2, even smaller than this. And what happened when I tried this experiment on my own was that as soon as we put even just a little bit of water in this bag, it was really hard to close it without having everything come out of the bag. So for up here in space, because of the way liquids behave and they conform to the shape of their container up here, just like they do on the ground, well, the shape of the container is a flat plastic bag, and so they end up making a flat shape and being hard to close. So we decided to go ahead and use a bigger bag up here in space. Okay. So that was about 8 mils before, and then we're going to get 7 here now. There we go. So we'll close our straw, take care of our water drop. And that's it for water. We'll put our bag away. And here is our water. Now you saw how much of a kind of mess that was just with plain old water. And so with pepper oil, now that's a bigger problem, and we really need to be able to know that with pepper oil we're not going to have that liquid out of control here on the space station. It would go everywhere. So I'm going to wear gloves and goggles, and what I did is I put some pepper oil in a bag already to be able to then pull out just 5 mils, because that was the easiest way to do that up here in space. Okay, now we're actually going to get another bag, Paolo. Good thing we have another bag, because this bag has a hole in it. There we go. Okay, let's put our bag in the trash here. Okay. So since we had to go to plan B, and my bag had a tiny little hole in the corner, I'm going to go ahead and just use an approximate amount of water here. So I think it's going to be good enough. Right about there. Okay. So here's our water. And I'm actually going to use my clip to kind of hold it a little bit. I'm changing the shape of our container a little bit just by holding it like that, so that it stays kind of with a wide mouth so I can get my pepper oil in there. Okay. There we go. Tuck in my paper towel there. And pepper oil is something that's pretty nasty to have floating around in the station, so we're actually pretty careful when we put it on our food. And when I'm playing with big amounts like this, it's definitely a good idea to have gloves, because it's not so easy to wash your hands well up here. And also goggles, because the last thing you want to do is have pepper oil in your eyes. So it's not a great fashion statement, but you know what? It's the way to go and do experiments. So I've got another syringe, and we want 5 mils, which is going to be halfway on this syringe here. 2, 4, 5. And here is my messy, messy, messy bag of pepper oil. Just gross. And the reason for that is, just like we were talking about, liquids up here are going to conform to the shape of their container. Okay, so here is my blob of pepper oil, and now it is going to go in our bag. Ready? And I know we're going to shake it up, so I'm not going to worry about how fast or slow I'm adding it. Okay. And you can take a look at that while I get rid of this very messy syringe and bag. Okay. Pretty neat stuff. So you can see that the oil and the water are separate right now. There we go. Just making sure we don't have any of that pepper oil around. Okay, there we go. Now, according to the procedure, we're going to shake this for 15 seconds. And you can see there's a big air bubble in the middle, and then you can see the little globs of pepper oil and water. So the water is kind of one continuous phase, and then the pepper oil is separate. And they have different densities, so you expect them to be separate. But let's see what happens when we really shake them up together, and they're really together. And it's kind of cool to see our little air bubble in the middle too. Okay, I guess since our oil's all in there and it's sealed, we can go ahead and take off our gloves here and our goggles. But you can see what happened is it formed an emulsion. So that means it's a really finely dispersed, very finely dispersed solution of one material inside the other. Now, on the Earth, I think I have to look back at the procedure, but I think it took about 45 seconds or so. We'll see how long it took theirs on the Earth back in Idaho at Potlatch Elementary School to separate. But I think it happened pretty quickly. At least that's what I think about when I think about salad dressing back on the Earth, is I shake it up and then just really quickly it's separated into oil and water again. And I expect the oil to float on top of the water because the oil is less dense. But this just doesn't seem to be changing. Let's see. And I wonder if we hold it up to the light. Let's see. No, it's a good light, Paolo. So you can see that this is really finely dispersed. The oil and the water are really well mixed, and then there's little air bubbles as well. So they're still distinct. I mean, there's tiny, what I see is really tiny little drops of oil in a solution of water. And it doesn't really appear to be changing. I mean, there's a big bubble in the middle there, okay? But then let's see what happens. Let's see if we can think of a way to create our own set of our own gravity here. And one way to do that is going to be to perhaps spin this bag. Let's see. And let's see what's happening when we do that. So the oil and the water go to one side, or go to all the sides because they're just separating out. Different. I don't think that was really enough of a force to change whether the oil and water felt enough gravity to basically break their emulsion and separate them out. And they look much the same to me. So let's try another way. You know, here in space, we actually think about how to separate out air and water quite a bit. And the reason we want to do that is that we have a lot of equipment that can push fluid through, liquids like water, but if you put air in there too, then it's going to confuse the machinery. And so we try to get the air out before we process the liquid. A lot of systems are like that. Even the bathroom is like that. And in our spacesuits, let's see, we still didn't put enough force in there. So no matter what I do up here, I can't seem to quite get these to separate. Now, if I put them in a centrifuge and really could spin them, could spin this, and so that there was really a force where one direction in this bag felt, where basically this bag felt some force like gravity, but created on here like in a centrifuge. You know how if you go around like on a merry-go-round, or if you're spinning around, spinning around, you're creating centrifugal force, and so that's going to force the heavier things to the bottom of the bag and the lighter things to the top. And if we did that with enough force, then we would be able to separate the water and the oil, because we'd break down the mechanical emulsion using mechanical energy. So, pretty different than down on the ground. Down on the ground, we know that oil and water would separate right away. But up here in space, they are really together. And understanding how things separate or don't separate is really important for a lot of processes down on the Earth. Whenever we're extracting oil from the ground, that's one way of separating some things. We want to understand how to separate them really efficiently. Whenever we do a chemical reaction and we make A and B, mix them together to make C, well, when we look at what we've actually got a lot of C, the thing we wanted to make, but we have a little bit of A left and a little bit of B left, so we need to be able to separate those things. And one way to do that is to understand which of those things would rather be with the oil, which of them would rather be with water, and put them with oil and water and find a way to separate those chemicals. And we use chemical reactions like that to create a lot of the things that we use every day down on the Earth. So this was really fun for us here on the space station. Paolo and I liked collecting the supplies that the kids came up with. They knew what supplies we had here on the space station, gave us a list to go find them, including pepper oil, knowing that we didn't have a lot of other kinds of oil up here. And we went and found those supplies, played with the experiment a little bit, and found out that sure enough, up here, where everything is floating around, including us, things behave differently, and it helps us understand how they behave on Earth. So, from the International Space Station, I'd like to say thank you very much to the kids at Potlatch Elementary School. I thought your experiment was great and interesting. It made me think a lot, and I enjoyed doing it, and I am looking forward to what other kinds of ideas you come up with next. So thanks for coming to the space station, and have fun at school. Welcome to the International Space Station, and specifically to kids in micro-G. We know a lot of kids down there on Earth are thinking about what happens to things up in space. Do materials behave the same? And kids have been asking us some really good questions, and some of those questions and some of those experiments were selected to be done right here on the International Space Station. And I'm Katie Coleman, NASA astronaut, Expedition 27, and we have been having a great time doing some of these experiments, and it makes us think about our environment here on this space station and what it's like to live in microgravity. I'll tell you that I love living in microgravity. I mean, look at our table here. This is our kitchen table where we all eat, and I don't know if you can notice, but it's not exactly horizontal, because on Earth we have horizontal tables so that our things don't roll off them. But here, nothing's going to stay on the table anyway. So we might as well have a table that doesn't take up too much room in our space station, which isn't all that big. So, today's experiment is from Potlatch Elementary School in Potlatch, Idaho. And these are students of Mr. Gary Lamb. And I think they also have been helped by Mr. Ed Galindo. And these are teachers that have gone out and found out how to use some of the great new resources that NASA has and bring them back to their schools, which is really great. So I'd like to say hello and thank you to Mr. Gary Lamb and his class. And I want to say hello to Cassie, Corey, Autumn, Bryce, Rebecca, Nathan, Brooklyn, Riley, Roger, Zachary, Levi, Kendall, Megan, Guadalupe, Levi, Haley, Marlon, Mackenzie, Megan, Bryce, Alexandria, Joe, Andrew, Gillian, or Jillian, I'm not sure, Amber, Fisher, Trina, Luke, Bryson, Devin, Jamie, Libby, Jordan, Elizabeth, Megan, and Blair. So, this is a great class, and they brought a really great experiment to us, which is the pepper oil surprise. What will happen to oil and water up here in space where we have just microgravity, just the tiniest little bit of gravity? You almost can't even notice it. In fact, you pretty much can't notice it. What happens to something where on Earth, the heavier water will be at the bottom and the oil will be at the top, and even if you shake them up for a long time, you're going to find that the oil and the water don't separate. Now, I had some questions to answer after we did the experiment, and here's our oil and water which is still emulsified, still tiny, tiny, tiny droplets of oil mixed in with water. And this circle in the middle here, that is not water, that is air. That's the air that was in our bag when I sealed it. And so everything that you see that's kind of yellow is a mixture of oil and water, specifically pepper oil. So does the water and oil go to the bottom of the bag? Well, it did at first when I squirted the water and oil in there, but that was really because it was sort of just finding a side of the bag to go to, and I actually directed it towards the bottom just so that I could close the top of the bag. Did the oil separate from the water and rise to the top or sink to the bottom? Well, it was pretty separate at the beginning, if you remember, because it has its own surface tension, which is different than water, and it doesn't really want to mix with the water until we mixed it up. Did the oil form droplets throughout the water? Well, that's my assessment. Yes, I think it did. I think the oil is in what we call a dispersion or an emulsion, and it formed droplets here in the mixture is really tiny, tiny little droplets of oil mixed in with water, and then our big giant air bubble. Let's see. Did the water or oil go to the outer edges of the bag? Yes, they did, didn't they? And I think that is because they're attracted to the surface of the bag, but also because this air in the middle, well, it's a fluid too, and it wants to stay all together too, and so it's going to form a shape where it can be all together, and so can the oil and the water. Does the arrangement of the water and the oil seem to be random? Hey, let me go back a question. Did the water or oil go to the outer edges of the bag? So that's asking whether maybe one of either oil or water, one of them wanted to be on the edges of the bag more than the other. And I don't think so. They look perfectly mixed to me. And I did this experiment, I think even a week ago, and this is exactly what it looks like today. It is still separated. It's pretty interesting to me. Does the arrangement of the water and the oil seem to be random? I'd say yes, except that you notice that we have our big air bubble in the middle of the bag, and so clearly the air wants to stay together and the oil and the water want to stay together, but they don't want to mix. We don't want, the air is not finely dispersed throughout our mixture. And is there anything interesting about the oil and the water that I observed? Well, it was interesting to me to do the experiment because it was a little trickier than I thought, mostly because of how we handle liquids up here in space. You know, these are our drink bags. This is how we drink. I've got water in a bag and a straw, and my straw has a little closer or a little crimper here, and that's so that I can actually keep water from coming out when I don't want it to. And I don't usually play too much with it, but I can show you how water comes out. And so usually when I have a drink, this is what I do. And it floats around, and it'll even hit me in the head if I'm not careful. But this is how we drink our drinks. We can't drink out of a glass because that water would be just everywhere, and it wouldn't be very practical. Okay. So I think we've answered all the questions, and I just want to say thank you very much to all the kids at Potlatch Elementary School. I thought you designed a really interesting experiment, and I liked doing it. So have fun down there.